You knew there wasn't a way that I was not going to take this thing apart. Let's get over and tear this thing to bits. Oh, the single band gooseneck antenna. I don't know. I don't know. What do we got to do to take this thing apart? Well, first off, the easiest thing to do is, it's already disassembled. The rubber band has come off. The gloves have come off. Try and twist this. See if something gives. I don't know. Oh, nope, something's moving. It's coming out of the bottom there. Getting warm. Okay, so we took that part out of the bottom, and that leaves us with this piece here. But what happened was it moved that way. The antenna moved down inside of the... It moved down this way, out that way. And there's something stopping it. Pliers. Making progress. Still stuck. That's metal. Did not expect that. We bent the tube. Broke the tube. There we go. All right, nothing left in that. And it has this clever little bit here to stop it from rattling, but it was rattling anyway. All right, just pull harder. I'm assuming that there was two sections of this sticky foam. There's a little bit there and a little bit there that prevented that from doing the thing. So I just pulled harder. Inside of the base of this tube is, I guess, a collar of some kind. All I see down there is foam. Yep, so I was right. There was another piece of foam in there. So there's a piece of metal inside of that, and this part here is metal, but I don't know if that matters. Other than, you know, it exists and it was accounted for in the math. I was wondering if there was some type of loading coil or something at the bottom of it, but it doesn't appear that there is. And at the top, flashlight. Yeah, there's just plain plastic down in there. So, nothing fancy going on inside the top of the tube. Okay, so we've broken it down to its constituent parts, and that leaves us with our antenna element and our SMA connector, and maybe there's something inside the base. Let's see, how long is that? That is, assuming that it's connected right at the base and nothing else is going on, it's about 15 inches, which is a little long, I think, for a 70 centimeter antenna. I'd be expecting somewhere around a foot. Nope, all I'm doing is twisting it around inside of my pliers. I had to run out to the garage and use the Dremel a bit. So there is the antenna element itself, and there is the pieces. So once I got this thing down to the part where I had cut through it far enough on both sides to start prying it apart, it started to unthread. So there we go. Down inside here, all we have is the other end of the SMA connector. And we had this little bit of a shield, I grabbed onto it with my pliers, that was around the outside, and it was insulated for some reason. And then let's peel this off and see what's underneath this tape here. What secrets are there yet? Okay, there's a little bit of a coil there. Interesting. Down inside is the socket. So this piece of plastic here will go inside of the metal socket for the SMA connector, and this will connect up to the outside. Let's get out our multimeter and see where that connects. All right, multimeter in beeper mode, center pin. Okay, so the center pin connects there, and then no outer pin connection. Excellent. What I was talking about in the last video about how handy-talkie antennas typically need some kind of counterpoise is just been proven because there is no shield connection to this antenna at all, which we already knew as ham radio operators. We already knew that, but now this proves it. This little piece of wire here was attached to the SMA connector. It looks like it's got some tinning on it, so it might have been soldered and then I broke it off. Under normal conditions, that probably wouldn't be an issue. Maybe after, you know, a couple of years of hard wear, that might be an issue, but you'll probably get tired of this antenna or that radio and forget the antenna was attached to it. Comes off of the SMA connector, wraps around 1, 2, 3, 4, 5 turns. That's a through turn? What is that? Let's do it this way. Okay, it comes off the SMA connector, it goes through the plastic, comes out the far side. 1, 2, 3, 4, 5, 6 turns through the plastic again, and then it connects to the radiating element. And this is all attached, not attached? Yeah. That's just one piece of wire. But it's a spring wound wire over top of some kind of form that's flexible. So even though you might think that it's wrapped up and that's some kind of loading device, it's really not, because it's all connected. It's all one big electrical hunk, if you know what I'm saying there. So overall, pretty interesting, really well constructed. I mean, I had to work at it to get it apart. There's all of the pieces of it, and it does the thing. It's 12 inches long. Let's see if we can get the information on the lower coil part. Turn that off, turn that into millimeters to make it easier. Let's zero it out. All right, my calipers tell me that we are, I said millimeters, 5.5 millimeters. Yeah, 5.5 millimeters wide times 6 turns. Okay, so using an online calculator, 6 turns on a 550 centimeter diameter core winding form with a length of 630 centimeters is 122 microhenries. 14 inches from the tip to the bottom of the line, from the tip here to the bottom of the antenna there, and then 122-ish microhenries of inductance have been added to it. Well, we made short work of that thing, didn't we? Still don't know why it was a gooseneck. The metal body of the antenna enclosing case, this being the antenna, the enclosing case being the piece of metal that enclosed it, probably had something to do with some interactions on it. 14-ish inch element with the loading coil. It loaded up really well. Thank you, dog. Well, the dog's here. I gotta go. Thanks for being awesome. Check out this video. We'll see you in the next one.